So I'm delighted to have with us this afternoon Mathias Merzman, the CTO of KHD. Mathias is someone with tremendous experience in the industry and a real perspective of all of the technology and how it can contribute not only to efficiency and profitability, but also to our efforts on climate change. So Mathias is also the famous producer of 4 excellent podcasts that I can recommend that he and I did together. So if you haven't listened to them, then please subscribe to the Clinker Factor and listen to us talking. We have a range of podcasts on technology. Anyway, I shall stop advertising our podcast, Mathias, and hand over to you. Welcome.
Thank you very much, Ian, for this very special, friendly introduction. But let me start with a compliment, giving it back to the organizers of this conference and also the presenters. I have to say I'm still caught by the quality of information that was given by the presenters up to now. And I hope I can keep up this quality here, and I like to start sharing my screen. I hope you can see that.
Yes, I can see that now.
Okay, perfect. So, ladies and gentlemen, good afternoon from my side. I'd like to continue the program and give you some information on flexible and efficient usage of alternative fuels and how KHD can support you in these endeavors. I've listened very carefully to the program up to now, and as I said, it was striking to me how well and how important these messages have been brought over by the esteemed speakers, Mr. Song, the chairman of the WCA, and Mahindra Singhi, we can say one of the big leaders of the cement industry and the high-level champions for climate change. They all came up with the same message, which is important and which came over quite clearly about the change that has to come about our industry and how urgently it is needed. And in my presentation, as you see from the title, I'm not focusing on CO2 this time, but I would like to take you on the first stage of our common journey towards sustainability in the cement industry. And as you know, every journey starts with the first step. And I will show you how the use of alternative fuels and low emission technologies come into play and perfectly tune into the roadmap towards sustainable and eco-friendly cement. So for those of you who might not be familiar with KHD as a company, I'd like to give you a brief overview on KHD and especially what drives KHD. KHD is a company with 165 years of track record in bringing in innovations into the cement industry, especially after, say, World War II, when the modern times of cement production began. KHD came up with a number of innovations into the industry, which form base of today's modern cement technology as such, beginning in the 1950s when KHD introduced the cyclone preheater that cut the energy consumption of clinker production by half, almost overnight. Then a series of other inventions have been introduced by KHD along the decades. And if I can now switch to my laser pointer, it would be easier for you to follow. For example, the calciner, which again reduced the energy consumption for the production of cement clinker. Then we came up with a short kiln. We came up with low NOx emission calciner technologies. We came up with highly efficient roller press grinding plants, all that with one target: to reduce the energy consumption, the cost, and the ecologic footprint of cement production. Now, in the recent years, we also came up with some inventions to provide benefits to the producers of cement and clinker, up until the product which I'm going to focus on today, the Pyro Rotor, has been introduced some few years ago, and also plants for calcined clay, which is a strong trend in the cement industry. We heard about that today already several times. We're also working on these technologies which Mr. Singhi and others have been widely talking about: carbon capture technologies, oxy-fuel, calcined clay, all these things which are necessary. However, let's put all that into perspective. I think the message has been delivered very clearly. There are pressing challenges for the cement industry. Like we've never seen it before in cement, we are confronted with a task that seems to be overwhelmingly big. And at the same time, we have no time to lose. It's time to act now. And the methodologies and strategies and cooperation approaches which are needed have been widely explained by my prestigious speakers before me. So I'd like to get ourselves back into the first actual steps on how to follow these roadmaps. Of course, the cement industry is always under production and cost pressure, given the relatively low price of this product. Then environmentally, we're going to talk about NOx reduction, mainly SOx also, and some other heavy metals, but NOx is a real big problem. And alternative fuels is a trend that is coming up very strong, and is also part of every decarbonization roadmap, and actually one that is able to save costs instead of increasing costs. And the overruling topic of everything we talk about, and we're gonna have to deal with for the next decade specifically, is CO2 reduction, of course. There are several roadmaps that have been developed. I'm showing just a few here. For example, the roadmap of the German Cement Producers Association, that is showing the way on how to act to achieve carbon neutrality. And you're gonna see it involves clinker manufacture, cement manufacture, logistics, and puts together a wide range of proposals to increase energy efficiency, to increase the use of alternative fuels, and to use hydrogen, to use CCUS technologies, for example. On the clinker, on the cement manufacturing side, we talk about new composite cements, reducing the clinker factor, using calcined clay, and all this. Another famous roadmap for decarbonization was published by the International Energy Agency and the World Business Council for Sustainable Development. And this compares the CO2 emission permissible in the next decades in order to reach the Paris 2 degrees goal. And it lists 4 levers which we have to apply in order to reach these ambitious targets. And if you see here, you see that we are going to have to utilize the substitution of fossil fuels as one important lever to get to our targets. And that's why I say this is the first step towards the carbon neutral and ecologically sound cement industry. If we switch over to China specifically, we see that there is a direct plan of the Chinese government that is being put in place, and that has massive investment and modernization implications for this Chinese cement industry. There's a plan for digital transformation of intelligent manufacturing in the building materials industry, and the requirements formulated here are very precise. This action plan defines concrete targets to key parameters for higher energy efficiency and CO2 emissions reduction. First of all, there will be a benchmark to be reached in terms of heat consumption per kilogram clinker that is considerably low at 670 kilocalories per kilogram. Secondly, the adoption rate of cement kiln waste heat power generation shall be enhanced over 90%. Thirdly, the comprehensive power consumption to produce, say, special type of Portland cement shall be reduced below 82 kilowatt hours per ton. The alternative fuel rate, the thermal substitution rate, shall become over 15 to 20%. Currently, it is at 7%. So you see, again, this is the first step towards decarbonization. And additionally, the production cost shall be decreased, of course, also by introducing smart technologies and zero pollution of the ecological environment for cement production. And that relates mainly to Nox reduction. So I will address these points and show you what KHD can do to support you in this quest. The essence of it all: ever more stringent emission limits will be implemented. Technologies to reduce CO2 will comprise maximized utilization of alternative waste-derived fuels. Ever more energy efficient production technologies will be used. Clinker substitution, in cement will call for grinding finer and more efficient. And on the long run, carbon capture technologies are needed. But as every journey begins with the first step, today we can immediately start going. And I'm not diminishing the necessity to start talking about decarbonization with carbon capture and calcined clay and oxy-fuel plants. But at the same time, we can start that journey through maximizing the use of alternative fuels. And we can start this journey by reducing our NOx emissions. KHD is also involved in carbon capture and oxy-fuel projects. We are developing products for this, and we are talking to clients in concrete projects already now to set up pilot systems for these new technologies. And I think we are all clear on the same understanding. We have to bring up these pilot systems in this decade in order to have them accessible, ready for use on a wide scale, beginning of next decade, or we will be too late. Okay, my subject today, alternative fuel technologies. And why is that so critical? We tend to believe that alternative fuels are fuels, which is in case true, but also not true, because these particles have never been fabricated to be used as fuels, which means they have properties which are not exactly ideal for combustion. This slide shows you, for example, one piece of plastic inside an RDF mixture that is rather small and rather thin, and this takes only less than 5 seconds to burn out completely. We've conducted combustion tests, and we've taken the time it needs to ignite, fully burn or weak flame burnout and char burnout. And you can see from the comparison of these two plastic parts, while the lower one is also not a big part, but it consists of more dense material, this burns out in only 30 seconds. And if you compare that to a coal flame or a fossil fuel flame, you see that the way this ignites and the way it releases its heat is completely different. And so the alternative fuel technologies have to take account of that. In order to do that, KHD has developed a wide range of technologies to use alternative fuels. On the left-hand side of this table, you see the most low-cost investment to start burning alternative fuels consists of introducing a pyrojet kiln burner ready to use, for example, biomass, plastics, RDF, and fluff to some certain size. And as this table develops to the right, you can see that the sizes of these alternative fuel particles increase up to the Pyrorotor that shows the biggest versatility for using even the biggest size of particles. Let me run you through the products very quickly. This shows the Pyrojet kiln burner, which is ready to take RDF and alternative fuels through its central tube. It is also prepared to run with oxygen enrichment and hydrogen enrichment. Another module which we can flange on every flash tube calciner is the so-called Pyro Incinerator. A very easy to flange on retrofit module that supports the ignition of the hard to ignite secondary fuels. So to boost maybe for some 20 or 30 percentage points the firing rate of alternative fuels with a low investment. Another module to be retrofitted is the so-called combustion chamber. I think that is a concept that is pretty well known already to many of the cement engineers. It's a separate reactor which features a real burner to produce a real open flame hot zone to facilitate the ignition of even harder to ignite secondary fuels. The product I'd like to draw your attention to with a special feature today is the Pyrorotor combustion reactor. That's a new type of secondary fuel reactor, which consists of a rotary drum, which provides many benefits for the combustion of secondary fuel. Its constant rotation provides new surface for the accessibility of the material to oxygen and hot zones. There is no clogging, no sticking, as would be the danger for such very lumpy material combustion on grate systems. In systems where you have a fixed grate, sticky material can form agglomerations and disturb the whole process. This is not possible in the Pyrorotor combustion reactor. Let me show you, I hope this works. Okay, the functional principle of the Pyrorotor, which you see here, it is being supplied with some portion of the tertiary air, which we branch off from the tertiary air line. And then it releases its off gases into the calciner, where it mixes with the kiln exit gases. We can play with the amount of oxygen we're gonna offer for this combustion here, so we can produce also a lean gas that helps reducing the NOx emissions from the kiln. So you can see it's a very robust design, a very simple process, you can say. And accordingly, the market is accepting this product quite nicely. We have sold so far 7 references, 4 of them are running today, and the type of fuels we are using is very wide and contains up to whole tires. And in China, also applications with hazardous wastes are running. And that's very lucrative at the same time for the clients because of the gate fees they could get for this material. The Pyrorotor can be fit in almost any environment as long as there's a tertiary air duct. It can fit in line with the kiln arrangement, like you can see on the right-hand side, but it can also run perpendicular to it in a 90 degrees angle, as you can see in this project. There's always space available for the Pyrorotor, and portion of the Pyrorotor is outside the tower structure. So we will have no much problem in finding a way to retrofit the Pyrorotor into any given structure from KHD make or other suppliers makes. Let me now spend some few minutes on Nox Reduction Technologies. And this is also very pressing. The picture I'm showing here is a map of NOx concentration in China. Not to say that China is now the culprit of it all, but the other regions also do have NOx emissions. It's just giving an example here, and it shows why the Chinese government has taken so drastic measures to force the industry to reduce their NOx emissions. For NOx reduction, we have developed the Pyro Redox module, which you can see in dark gray in this picture. It's an addition to the calciner, which allows to reduce the NOx emissions down to levels which you can otherwise only achieve by using high investment SCR catalyst technology. If you look at this diagram, you'll see the NOx emission level on the left-hand side, and you see several technologies which have been used over the course of time. With the pyroclone low NOx calciner back in the second half of the 80s, we could reach levels down to 500 milligram. But this is not enough. Then the SNCR technology came up. When spraying ammonia and doing it right, you can reach levels up to 200 milligrams or maybe 500 milligrams. Now the Pyro Redox gets down to this level without using ammonia. That saves money and avoids ammonia slip. And if we combine Pyro Redox with SNCR, we're getting down to numbers comparable to catalyst installations, SCR installations. However, these require massive retrofits in the preheater and massive CapEx and OpEx investments, which is much cheaper to be solved with the Pyro Redox technology. Pyro Redox, as you see here, acts like an upfront extension of the calciner, where we connect the kiln exit gas into this Pyro Redox loop, and then later on mix tertiary air into it and have the regular calciner. This simple process design allows for very efficient reduction of NOx in the kiln, and also provides a lean gas that is easy ignitable later downstream in the calciner loop. Together with the Pyrotop mixing chamber, we dissolve all CO strands and run into the preheater system with a low NOx level and a low CO level. It is available for use with alternative fuel. It is available with conventional fuel. It's a very simple and robust technology. You can see the retrofit of a Pyro Redox in dark gray, as it is retrofitted into an existing calciner structure. It's a simple tube, not complicated, no moving parts, very simple to install and to operate. We've done several retrofits, especially also in China. This slide shows you some pictures of a Pyro Redox retrofit onto the Tianrui Weihui plant, a 5,500 tons per day plant before and after retrofit. You can see there is not much complexity involved, and accordingly we've done several more installations around the world, but very intensely in China because of that very stringent NOx limitation in China. The size of the plant doesn't really matter. This concept works for all kinds of plants. I know that in China, there's a strong differentiation always according to the production capacity of the plant, but process-wise, it's all the same. And this principle works for all kinds of plants. The results I'd like to show you from some of these plants are very encouraging. And for example, what I show here is the results and the performance of the system after this initial commissioning. We have to get to a limit of below 50 milligrams here. And at the first commissioning, we could already achieve a significant abatement of NOx below 100 milligram per normal cubic meter or 50 milligram. I tell you the numbers in diagrams later on. Also, the ammonia injection was reduced massively, as you can see, and this speaks for itself for the efficiency of this inherent NOx reduction. There was no reduction in plant capacity, there was no increase in fuel consumption, there was no increase in power consumption. That's a huge difference to the SCR technology. If you look at the trends, they show you clearly what I've just mentioned. If you look, for example, at the green line, and the respective scale is here, that is the NOx emissions in milligram per normal cubic meter. And the yellow line is the ammonia injected. And you see, here's the startup phase, and there was no fuel put to the redox, which means the redox didn't work as redox, so it was off. Now we put the Pyro Redox into action by shifting fuel to the redox loop, and accordingly we can reduce the NH3 injection, and still the NOx reduction is decreased. And this could be improved further on. We put more fuel to the Pyro Redox, and we could reduce the ammonia injection significantly, as you see, while still the NOx emission was low. But this was only an initial commissioning. We then optimized the plant, and I show you this picture here, which shows the NOx emission level in milligram per normal cubic meter as this blue curve. And we see also the ammonia injection in this magenta curve. And you see that we ended up with emission levels averaging around 26 milligram per normal cubic meter, with a very low ammonia injection in the range of 1 milligram per normal cubic meter. So this underlines the powerful performance of this. We speak of an inherent integral NOx reduction by the Pyro Redox system. To come to a summary, the cement industry needs to implement new technologies to reduce cost and emissions. That's clear. KHD offers these technologies with flexible and retrofittable modules for increased utilization of alternative fuels. We have the whole range of products, as I have shown to you in that table. And the top line product is the Pyro Rotor for the highest substitution rates at lowest preparation costs, which means, especially in cases where you don't have access to high quality pre-processed secondary fuel, but you have access to cheap, rarely pre-processed coarse size material, the Pyro Rotor is the best solution. And KHD offers also cost-efficient NOx reduction technologies. As an example, I've shown the Pyro Redox for lowest NOx emissions at low CapEx and OpEx. And I'd like to close my presentation today with a saying from Master Confucius. He said, "He who does not care about the future will have plenty of sorrows very soon. I guess we all agree to this, and we all see the pressing urgency that we are in as a community. And we as KHD, we are sure we can achieve these goals only by very tight cooperation between clients and customers, authorities, research partners, other industrial sectors. This is what we have to apply. We have to cooperate. And if we do so, I think we can reach the targets, but we have to get going. So let's get things done together. Thank you very much for your attention.